Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled Planet X Reveals Why Everything Rotates and What Particles Look Like. Now, in Article 572 entitled Planet X Trajectories, Why Are They Curved?, I show that Planet X system stellar cores follow curved paths as they move in towards the Sun, and that newly created planets start out having rotational motion because their parent star is already rotating. But why does the parent rotate? This has to be due to particles themselves rotating. And this diagram illustrates why everything in the universe, how we know that everything rotates. This is the Andromeda Galaxy, and we know that the galactic core rotates. We know that star clusters orbit the galactic core, and large stars in star clusters will have smaller stars and planets orbiting them. Also, each star and planet will also rotate. Thus, all objects in the galaxy have both orbital and rotational motion. Now, matter and thus particles appear when the core of a celestial object goes through a matter creation event. This occurs when the gravitational energy in some region of the core surpasses the electric potential, which results in the release of some gravitational energy. And you may look at Article 569 entitled Effect of Planet X Objects as Large as the Sun on the Earth, Energy Levels. Gravitational energy is photon energy. In other words, it is photons which exist within particles, and photons is of course light. So this means that the release of gravitational energy is the same as the release of photons from within particles, which thus emerge as free photons or light and immediately are converted to matter or particles. The process is the same as what is described in accepted physics theory as particle-antiparticle creation, except that there is no such thing as an antiparticle. All we have is two particles of opposite charge emerging from within a photon. The mass of the two particles depends on the energy of the photon. The particle pair only has the same mass when the photon energy is low, in which case one of the particles is an electron, the other is a particle with the same mass but oppositely charged, in other words positively charged, and is called a positron. A more energetic photon with an energy of about 1000 MeV causes the particle pair to be an electron and a proton. And you may look at Book 3 entitled Planet X Reveals Gravity and Light, and Article 196 entitled Stellar Cores, Particle Mass and Replicated Technology. And this is illustrated by this diagram, how when a photon, which is released by the plasma core inside a celestial object, goes through a region of high electric field, it causes two oppositely charged particles which were already inside it to be pulled apart, causing the photon to split and the particles to move to the outside of the photon. The photon transforms into energy in the form of mass for the two particles, and what is left becomes gravitational energy shared equally by the two particles. The particles must somehow start rotating as well. Now, we know that all charged particles have magnetic moments. In other words, they have intrinsic magnetic fields, and since magnetic fields arise from charged particles moving along circular orbits, there must be a charge inside each particle moving in a circular orbit. This suggests that the charged particles which emerge from inside the photon start orbiting the photon, which is thus like the central star for the particle. And I'm going to call the massless particles negaton and positon. So we start with a free photon moving at the speed of light, and we see the two particles inside it, the negaton and the positon, and it moves through a region of high electric field which causes it to split into two parts, so basically two photons. And the particles now move to the outside of the two photon pieces and orbit those photon pieces. And the fact that they orbit or move have circular motion gives rise to the magnetic field of the two particles. This one's the electron and that one is the proton. So this illustrates particle structure then, where massive particles are like a simple star system. The charged particles, the negaton and positron, start out inside a free photon, moving at the speed of light, and remain massless even outside the photon. They are still massless here. The photon has a core and an outer layer. So here's the core in orange and the outer layer in yellow. When the photon moves through a region of high electric field, the charged particles inside the photon separate, causing the photon to split into two parts and slowing its speed dramatically. The negaton and positron then orbit the two resulting photons, which thus become like central stars to them. Mass comes from the size of the photon core, the orange part, at the center of the orbit. The outer photon layer is the particle's gravitational energy. So this yellow part is the gravitational energy, which allows the gravitational interaction to take place. The negaton and positron remaining massless makes it possible for the two particles resulting from a photon splitting to have different masses depending on the energy or size of the original photon core. In other words, we could get an electron and a positron, an electron and a proton, or a proton and an antiproton, or any other hadron pair of opposite charge. The orbital motion of the charged particles gives rise to the electrons and protons' magnetic field, which are represented by the green arrows. Since the negaton and positron orbit the photon as if the photon is a central star, we would expect the photon to also rotate. Hence, the straight line speed of the photon and of the two massless charges is transformed into orbital speed for the two charged particles and rotational speed for the photon at the center of each particle. Particles with less gravitational energy will tend to orbit those with more gravitational energy, thus resulting in celestial objects having higher gravitational energy centers and rotating about an axis through their centers. Magnetic fields of particles will tend to also align, thus building up to a large magnetic field for the whole celestial object. And here you have illustrated how two protons would combine and one would orbit the other. So there are two protons, and two protons attract each other due to the gravitational interaction, and the gravitational interaction is represented by this yellow line here, which connects the two. So it's actually photon connecting to photon. And it's actually the gravitational energy part of the photon which goes out and connects to the other outer layer of the other proton, or the photon at the center of the other proton. So the photon at the center of each proton rotates and the protons orbit each other. The positive charges, the positons, will repel each other through the electrostatic interaction, stopping protons from ever colliding. So these are the positons orbiting on the outside, and they will repel each other, so they will keep the two protons from ever getting too close. And there you are. Now, the photon core is associated to the mass of the particle, in our example a proton, which never changes, and the outer layer is associated to the gravitational energy of the particle, which can change. The electric potential is given by the energy level or orbit of the charged particle. In other words, how close the charged particle orbits to the outside layer of the proton, of the photon at the center of the proton. And so if the gravitational energy or potential is too high for the electrical potential, in other words, if this outer layer goes out too far so that it gets too close to the orbit, then some of the gravitational energy will be released. And that will then result in a photon being released, because when gravitational energy is released from the inside of a proton, it emerges from it as a photon. And so this is illustrated by this diagram here. If we have too much gravitational energy, then the outer layer will look fat like this. It will get too close to the orbit of the positon, and that will trigger a release of gravitational energy. And so it will trigger release of photons, and photons are quantized. So all energy releases from particles will be quantized. In other words, it will be released as a number of packets or quanta. And so in conclusion, understanding of how matter interacts through the gravitational and electrostatic interactions arising out of Planet X observations has now led to the understanding of how particles are structured, where photons are like a central star and a massless charged particle orbits it. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.